limiting reagents and excess reagents. So to this point in stoichiometry, we have dealt with everything in excess. But we also have a limiting reactant. So consider you have two or more reactants. One of them is going to run out or be consumed before the other. That reactant is called your limiting reactant. It's going to limit how much product you can form. In these types of problems, you're going to have to determine how much product can be formed from each reactant, and that'll allow you to see which reactant is in excess and which one is our limiting reactant. Let's begin by visualizing limiting reactants. I've created a fictitious chemical reaction where we have one hot dog plus one bun yields one hot dog in a bun, HDB. So in our image here, we're given 5 hot dogs and 4 buns. The question is, how many hot dogs can you make? What is the limiting reagent? And what is the excess reagent? I can tell that visually what my excess reagent is and what my limiting reagent is, but let's apply the math like we would if it were a real chemistry equation. How many hot dogs in a bun can I make from 5 hot dogs? Using my balanced chemical equation, I know that I can make 5 hot dogs in a bun from 5 hot dogs. Now, we do the same thing for our buns. We need to do this for each reactant. With 4 buns, mathematically we can see that we can make 4 hot dogs in a bun. Now, we have to think through the step, which makes the least. In this case, it's our 4 buns. So how many hot dogs in a bun can we make? 4. We can only make 4 hot dogs in a bun. Buns are our limiting reagent. They ran out first, they were consumed first, and thus they limited how many total hot dogs in a bun we could make. Hot dogs are our excess reagent because we have excess hot dogs. We have hot dogs left over. That makes them our excess reagent. Again, this hopefully helps you to visualize limiting and excess reactants. Let's take a look at an example next of a real chemical situation. Calcium oxide reacts with water to form calcium hydroxide as the only product. First step, determine the mass of calcium hydroxide formed from the reaction of 4.44 grams of calcium oxide with 7.77 grams of water. Second part, state our limiting and excess reactants. As with all other stoichiometric calculations, it always begins with a balanced chemical equation. Calcium oxide reacts with water to form calcium hydroxide. Hydroxide has a -1 charge, calcium a +2, so I'm going to need 2 hydroxides to cancel out the +2 of the calcium. Otherwise, my equation is balanced. Calcium oxide is a solid, water is a liquid, calcium hydroxide is aqueous. Next, we need to determine how much product each of the reactants can make. It doesn't matter which value you start with, so I'll go ahead and start with the first one given to us, the 4.44 grams of calcium oxide. So how much product, calcium hydroxide, can we make with the 4.4 grams of calcium oxide? First step, convert our mass of calcium oxide into moles of calcium oxide. We use our periodic table, we'll add 1 calcium and 1 oxygen to gain a mass of 56.077 grams per mole. Next, we use our balanced chemical equation to go from moles of calcium oxide to moles of calcium hydroxide. Finally, we'll use the mass of calcium hydroxide, the molar mass of calcium hydroxide, to convert back to grams of product, or grams of calcium hydroxide. with my 4.44 grams of calcium oxide, I expect to make 5.8663 grams of calcium hydroxide. With significant digits, 5.87 grams of calcium hydroxide. But I'm not done, because I still need to figure out how much calcium hydroxide I can make with my other product, my 7.77 grams of water. Again, the first step, convert from grams of water into moles of water. Now that we have moles of water, convert to moles of calcium hydroxide. We'll use our balanced chemical equation, 1-to-1 ratio there. Finally, moles of calcium hydroxide to grams of calcium hydroxide. Crunch our numbers with significant digits. We're going to get 32 grams of calcium hydroxide will be made from 7.77 grams of water. I need to compare these two values. Which one can I actually make? You want to choose the smaller of the two amounts, 5.87 grams of calcium hydroxide. With 4.44 grams of calcium oxide, I can only make 5.87 grams of calcium hydroxide. What happens if I try to make 5.88 grams of calcium hydroxide? I've got enough water, for sure, but I will have run out of my calcium oxide. I'm limited to only 5.87 grams of calcium hydroxide with 4.44 grams of calcium oxide. So to answer part A, only 5.87 grams calcium hydroxide can be produced. Part B, calcium oxide is my limiting reactant. It ran out first. Water, in this case, will be my excess reactant. I can make more than enough calcium hydroxide with my amount of water, and I'm going to have some water left over. It is in excess. It is my excess reactant. A word of note, be wise. Just because one of the reactants has a smaller starting amount does not automatically make it the limiting reactant. In fact, it's probably only 50% of the time that the value that is smaller to start with is indeed your limiting reactant, as it is here. Always do the math, complete all the steps, and solve for the smallest amount of product and choose that as your limiting reactant.